Next question is question number 12. Question number 12 is you have to integrate I is equal to, sorry, question number 11 we have to solve. Question number 11 is you have to integrate sin x plus cos x divided by sin x minus cos x dx. Note that derivative of sin x is cos x, that is written here, and derivative of minus cos x plus sin x, the derivative of minus cos x is plus sin x. This means that the derivative of the denominator is given in the numerator. Therefore, this directly becomes equal to natural log of sin x minus cos x plus constant of integration. Instead of this, you can solve it by more sensible manner. So you have to put the term whose derivative is given, it should be equal to some other variable. So we will put sin x minus cos x is equal to some other variable t. This means that dt is equal to the derivative of sin x is cos x minus the derivative of cos x is minus sin x multiplied by dx. So this means that dt is equal to cos x plus sin x or sin x plus cos x dx. Now you can put these values in your integral. It becomes equal to I equal to, instead of sin x plus cos x dx, you have dt, and divided by, instead of sin x minus cos x, you have t. So now this obviously equal to natural log of t plus constant of integration, and this comes out to be equal to natural log of, instead of t you have to write sin x minus cos x plus a constant of integration. This is equal to I. This is your answer. Next question is question number 12. You have to integrate I equal to sine square root x divided by square root x dx. This is very simple question. Just you have to put square root x is equal to t. So dt looks like to be equal to 1 divided by 2 square root x dx, because the derivative of square root x is 1 divided by 2 square root x. So from here, since the given values in the integral are dx divided by square root x, so we will separate the dx divided by square root x from here, and we will get 2 dt. So now we are left with I equal to sine, instead of square root x we have put t, sine t, and instead of dx divided by square root x we have just 2 dt. 2 has to be taken out of the integral, and you are left with sine t dt, and this is equal to 2 multiplied by minus cos t plus constant of integration. Replace back the value of t, cos, and instead of t we have square root x plus constant of integration. This is the answer. Next question is question number 13, and in this question you have to integrate square root of e raised to the power 2x plus e raised to the power 3x dx. For this, I is equal to, take e raised to the power 2x common between the first two terms. you have 1 plus e raised to the power x. So now separate the square root. You have e raised to the power 2x multiplied by square root of 1 plus e raised to the power x dx. 2 gets cancelled with the square root since it is in the power, because e raised to the power 2x can be written as e raised to the power x whole square. Therefore, when you will take the square root, you're left with just e raised to the power x. So apply it just here. You will get 1 plus e raised to the power x whole power 1 by 2 multiplied by e raised to the power x dx according to the commutative law of multiplication. So you can see that the derivative of the base term is given. The base term is 1 plus e raised to the power x. Its derivative is obviously 0 plus e raised to the power x, that is e raised to the power x. It is given just in the front, therefore you can apply the power rule of the integrals. So 1 plus e raised to the power x whole raised to the power 1 by 2 plus 1 divided by 1 by 2 plus 1 plus constant of integration, that is 1 plus e raised to the power x whole raised to the power 3 divided by 2 divided by 3 divided by 2 plus constant of integration. 2 has to be taken in the numerator, so 2 divided by 3, 1 plus e raised to the power x whole raised to the power 3 divided by 2 plus constant of integration. Hopefully this is the answer. Let me check it. Yes, it is the answer. The next question is of the same kind. Question number 14. In this question you have to integrate dx divided by e raised to the power x plus e raised to the power minus x. There is no square root, so I is equal to integral of dx divided by e raised to the power x plus 1 divided by e raised to the power x. Apply the LCM, you might get dx divided by e raised to the e square x plus 1 divided by e raised to the power x. Again, e raised to the power x has to be shifted to the numerator, and you have e raised to the power x divided by e raised to the power 2x plus 1 dx. This is the simple question. Now you can put here e raised to the power x is equal to t, so that dt is equal to e raised to the power x dx. So now your integral I is equal to, instead of e raised to the power x dx in the numerator, you have just dt, and in the denominator you have e raised to the power 2x, that is t square plus 1. So this is the integral of tan inverse t. So tan inverse, and instead of t you have e raised to the power x. So hopefully this is the answer. Let me check it. Yes, this is the answer. Now we will solve the next question. Question number 15. In this question you have to solve the integral of e raised to the power 2x divided by square root e raised to the power x minus 1 dx. This integral can be written as, you can break ex e raised to the power 2x in e raised to the power x multiplied by e raised to the power x divided by square root e raised to the power x minus 1. Now this is more simpler. You have to put e raised to the power x is equal to t, so that dt is equal to e raised to the power x dx. And now your integral I is equal to, first e raised to the power x is replaced with t, and the second e raised to the power dx is replaced with dt, divided by square root t minus 1. Make the numerator like the denominator, therefore you have to add and subtract 1. T minus 1 plus 1 dt divided by square root t minus 1, and you have to separate the denominator. And now you have to apply the distributive law, and you have to further simplify, so that you have in the numerator t minus 1 dt plus similarly t minus 1 raised to the power minus 1 by 2 dt. Apply the power rule because the derivative of t minus 1 is 1, that is given in front. Therefore, you can apply the power rule. According to that rule, t minus 1 whole raised to the power 3 by 2 divided by 3 by 2, that is 2 by 3 in the numerator, plus square root t minus 1 divided by 1 by 2, that is 2 square root t minus 1, plus constant of integration. Now put the values back. T is equal to e raised to the power x. So you have e raised to the power x minus 1 raised to the power 3 by 2 plus 2 square root e raised to the power x minus 1 plus constant of integration. Let me check it. This is the answer. There are made some of the simplifications. Let me do them. All the first 2 divided by 3. Since we know that we can write x raised to the power 3 by 2 equal to x multiply x raised to the power 1 by 2. So this is equal to, we can write here e raised to the power x minus 1 multiply e raised to the power x minus 1 whole raised to the power 1 by 2, that is square root ex minus 1, and plus 2 times square root e raised to the power x minus 1 plus a constant of integration. All the first you have to take out the square root e raised to the power x minus 1 as a common. You're left with 2 divided by 3 e raised to the power x minus 1 plus 2 plus the constant of integration. In the next you have to take out the common 2 divided by 3. So you have 2 divided by 3 e raised to the power x minus 1, and since 2 by 3 has been taken common, you have e raised to the power x minus 1, and multiplied the 2 with 3 divided by 2 plus constant of integration, because you have taken 2 by 3 common. This means that you have to divide the inside terms by 2 by 3. Therefore, when you will divide 2 by 3, you have just 3 left. Therefore 2 gets cancelled with this 2, and you have 2 divided by 3 square root e raised to the power x minus 1 e raised to the power x minus 1 plus 3, that is plus 2 plus constant of integration. Let me check again. Yes, now this is the answer written in your answer manual. Next question is also very simple. Question number 16. In the question number 16, you have to integrate a very simple question: cos natural log of x divided by x dx. You have to put ln x is equal to t, so that 1 divided by x dx is equal to dt. Now your integral reduces to cos ln x, that is equal to t, and dx divided by x is equal to dt. Very simple question. This is equal to sine t plus constant of integration. This is equal to sine, and instead of t you have ln x, sine ln x plus constant of integration. So this is your answer. Let me check it. This was question number 16, and the answer of question number 16 is sine ln x. Yes, this is the correct answer. The next question is also quite simple. Question number 17. And in this question, you have to integrate you have to integrate 2x plus 5 divided by x squared plus 5x plus 7. Very simple question. If you want to solve it systematically, you have to solve it with the same method as I described in the question number 7. If you want to solve it directly, then follow me. I is equal to x squared plus 5x plus 7 whole raised to the power minus 1 by 2, and the next term is 2x plus 5 dx. You can notice that the derivative of the base term, that is x squared plus 5x plus 7, its derivative is 2x plus 5, that is given just in the front. Therefore you can directly apply the power rule of the integrals. X squared plus 5x plus 7 divided by whole raised to the power minus 1 by 2 plus 1, that is 1 by 2, and you have to divide with 1 by 2 plus constant of integration. This is the answer, which can be written as 2 square root x squared plus 5x plus 7 plus constant of integration. Next question number 8 is of the same kind. Question number 18. It is x divided by x plus 2 dx divided by square root 2x squared plus 8x plus 5. Now notice that the derivative of the denominator term is 4x squared plus 8, that is you have to multiply and divide by 4. So 4x plus 8 divided by 2x squared plus 8x plus 5 dx. So you have 1 divided by 4 integral of 2x squared plus 8x plus 5 raised to the power minus 1 by 2 and 4x plus 8. This is similar to the previous one. Apply the power rule. 1 divided by 4, 2x squared plus 8x plus 5 whole raised to the power 1 by 2, that is square root. divided by 1 by 2. This 2 gets cancelled with this, and you have simply the answer 1 divided by 2 square root 2x squared plus 8x plus 5 plus constant of integration. So that's it from our lecture. Next question is question number 19. This is also quite a very simple question. In this question you have to integrate I equal to square root x square minus a square divided by x raised to the power 4. Since there is x square minus a square, and we know that we can substitute x equal to a secant theta, but more useful substitution here would be x is equal to a cos hyperbolic theta. Therefore I would substitute x equal to a cos hyperbolic theta, and definitely its differential would be a sine hyperbolic theta d theta. Substitute these values back into your original integral. You get I equal to square root of a square cos hyperbolic square theta minus a square divided by x raised to the power 4, that is a raised to the power 4 cos hyperbolic raised to the power 4 theta, and in place of dx you have to write a sine hyperbolic theta d theta. Next you have to simplify. Take a square as common and take it out of the square root. It would become a square has been taken out of the square root, and we are left with cos hyperbolic square theta minus 1, that is sine hyperbolic square theta divided by a raised to the power 4 cos hyperbolic 4 theta and a sine hyperbolic d theta. In the next step, simplify the terms. You're left with a multiplied with a is equal to a square, and a square gets cancelled with the a raised to the power 4 in the denominator, and we have 1 divided by a square left. Square root gets cancelled with the square, and sine hyperbolic theta gets multiplied with sine hyperbolic theta, and it becomes sine hyperbolic square theta. Divided by cos hyperbolic 4 theta, which could be written as cos hyperbolic square theta multiplied by cos hyperbolic square theta d theta. So this comes to be equal to tan hyperbolic square theta, and 1 divided by cos hyperbolic square theta is secant hyperbolic square theta d theta. We can see that the derivative of tan hyperbolic theta is given in the very front, that is secant hyperbolic square theta, and therefore we can apply the power rule of the integrals, and we get 1 divided by a square tan hyperbolic cube theta divided by 3 plus a constant of integration. Now you have to put back the values. You have 1 divided by a square multiplied by 3. Tan hyperbolic cube theta is equal to sine hyperbolic cube theta divided by cos hyperbolic cube theta. You can write these two cubes into a single combined cube plus a constant of integration. Since we have substituted x equal to a cos hyperbolic theta, and we can write sine hyperbolic theta in terms of cos hyperbolic theta, and we know that how we do this. This is equivalent to cos hyperbolic square theta minus 1 whole square root, and divide by cos hyperbolic theta has to be written as it is, whole raised to the power 3 plus the constant of integration. Now you have to put the values of cos hyperbolic theta here. Cos hyperbolic theta is equal to x divided by a. We will substitute this value of cos hyperbolic theta down here, and we will get 1 divided by 3a square. In the square root we will get x square divided by a square minus 1 divide by, and instead of cos hyperbolic theta we will simply write x divided by a whole cube plus a constant of integration. You have to further simplify it, and you might get 1 divided by 3 square root of x square minus a square divided by a square, which gets out of the square root, and you have a multiplied with x, and in the numerator you will get a and its whole cube. Here it was a square, a gets cancelled with a, and you have the final answer, which is 1 divided by 3 a square x raised to the power 3 and x square minus a square whole raised to the power 3 divided by 2 plus constant of integration. This was a very simple question. We'll check its answer. Question number 20. Question number 19. Yes, the answer is correct. Next we will solve the question number 20. This is also very simple question. In the question number 20 you have to integrate cos raised to the power 6 6x multiplied with a sine cube x dx. Rewrite this integral as cos raised to the power 6 x and sine square x multiplied with sine x dx. Why it is done, you will understand this in next few steps. Cos raised to the power 6, and instead of sine square x you have to write 1 minus cos square x. Sine x dx has to remain as it is. Next you have to put cos x is equal to some other variable. This simple question can be solved with many techniques. I will seek for the simplest technique for you. You have to put t is equal to cos x, so that you have dt is equal to minus sine x, or sine x is equal to minus dt. sin x dx is equal to minus dt, and you have to substitute back these values into your original integral. You might get, instead of cos raised to the power 6, you might get t raised to the power 6, because we are putting t is equal to cos x 1 minus t square, and instead of sin x dx, you might get minus dt, and minus has to be written out of the integral. So now it looks like a more simple, actually very simple question, very simple problem. Take minus inside and multiply it. You might get t raised to the power 6 and t square minus 1 dt, and from here you get t raised to the power 8 minus t raised to the power 6 dt. Apply the power rule of the integrals. You get t raised to the power 9 divided by 9 minus t raised to the power 7 divided by 7 plus a constant of integration. Write the value of t, that was equal to cos x. So cos x raised to the power 9, that is cos 9x divided by 9. Similarly, cos 7x divided by 7 plus a constant of integration. So this is the answer.